Hello, wonderful scholars. We're going to do the 9.1 practice question, number one. Um, well, here we go. We're going to do a test on the claim about apartments. It says the mean of several thousand apartments in a new development in Rosemont is advertised to be 1,250 square feet with a standard deviation of 38. So there we go. Okay, that's what they're claiming. A tenant group thinks the apartments are smaller. Uh-oh, smaller than advertised. Okay, after taking a sample of 150 apartments. And they found that the average square footage to be only, let's put this in orange, only 1240. Does the tenant group have a significant evidence? Alpha equals 0.05. That's new. What does that mean? We'll talk about that. Okay. Do they have significant evidence that the new development is using false advertising? All right. The population is several thousand apartments. That are being built in Rosemount. Okay. The parameter is the mean square footage of an apartment of one apartment. Okay. The general equation of the test that we're going to use is z. We're going to get a z-score. It's going to be the x bar of the sample minus the parameter divided by the standard deviation. Well, it's actually going to be sigma divided by root n. I said, why is it sigma? Because we're going with what they're claiming. They're claiming this is the standard deviation for all of the population. That's kind of semantics. All right, now we're going to do what's called a full significance test. This is my little acronym to help you remember the steps. So, HI-TAPSY, HI-TAPSY. HY is the beginning of hypothesis. Okay, so what are, I guess it's hypotheses. What is the null hypothesis? And what is the alternative hypothesis? Scoot you down a little bit. The null is shown as H subscript 0 is that it's what they're claiming up here in green. They're claiming this. So that's the null, that the mu of all the apartments is 1250. The alternative with a subscript A, a little a for alternative, is, now I gotta think here, is this going to be a one-sided test or two-sided? If it's one-sided, which way is it? And I highlighted it here to help us. The tenant group thinks the apartments are smaller than advertised, smaller than 1250. So our alternative is that the average is less than 1250. So that's HY in HI-TAPSY. T is just name the test. This is a one sample because t-test. It's a t-test because it came from a sample that we got an X bar from. A stands for check your assumptions. The three assumptions that we've been checking a lot. Number one, is it random? And right away I'm a little concerned because I said, oh, well, it just said a sample. It didn't say anything about being random. So I'm going to say not stated as random. So that's a bit of a problem. So we're going to proceed with caution. Okay. The second assumption is it approximately, those are the two worst squiggles ever. Is it approximately normal? And the sample size is big enough. The sample size was 150 apartments. That is greater than 30. So that satisfies the central limit theorem. Number 3, is independence satisfied? We could do sample size. We could do the 10n rule. 10n would be 10 times 150. That equals 1,500. Is that less than the population of all the apartments that are being created? And it is, because it says up here that it was several thousand apartments. So check, it's less than the population. You could even add a little qualifier, population of all the apartments, of all apartments. Check. So there's my HY was my hypotheses, T for test, A for check the assumptions, P means to do the work. It's short for get the p-value. In other words, get the probability of a result like this. They got a result of an average of 1240. What's the probability of that happening? So we are going to get a z-score using that formula up right here, and look it up in the green packet. So z-score equals x bar, that's the sample statistic, 1240, minus mu. Mu is, you can look back at your null hypothesis, it's 1250. And then you divide by the standard deviation. Remember, standard deviation is 38, but that's for a single apartment. We have a sample size to account for, so we're going to divide by the square root of n. So 38 over the square root of 150. All right, so that is 1240 minus 1250. That's negative 10, so it's 10 under the average, divided by, I like to guard the standard deviation like this with a parenthesis. And there's my z-score, negative 3.22. Okay. Now we can look this up. What is the probability of a z-score of less than negative 3.22? We're looking up in the green packet. And I'm on table A with the z-scores. We haven't done this in a little while. And here's negative 3.2 and 2, so right there. It's a very, very small percentage, 0.0006. So in other words, this is not likely at all to happen. As a quick little aside, what we've just done is we have modeled this with the normal curve. The null hypothesis is the center. We think 1250 is the average. We're checking against that. We got a result of 1240, which it turns out is quite a ways down from here, because the z-score for it is negative 3.22. So the likelihood of an outcome this low or lower is 0.0006. Okay? If in fact 1250 is a true average, then getting a random sample like this will only happen this often, which is really low. So what do we do with that? So P was p-value, C stands for what's the conclusion? So with P equal to 0.0006 and alpha equal to 0.05, okay, where'd that come from again? That was given to us, okay? What alpha is, it's the cutoff, you guys. If we get a p-value lower than 5%, we will say that that is significant, and we will reject the null hypothesis. Um, I've drawn this little line here. This might help. Um, we set alpha in here somewhere. In this case, it was 0.05. So 0 would be on the bottom, 1.0 would be on the top. Anything up here above alpha, anything up here means we get a p-value up here larger than 0.05. So you would fail to reject the null hypothesis, but anything down here, anything under alpha, you reject the null hypothesis. In other words, if the probability of your sample, like we have here, it's really low, it falls down, it's underneath alpha, it's underneath the 5% cutoff. So we call that significant. Okay, so let's finish it out. With p of 0.006 and alpha of 0.05, we will reject H naught, H null. H naught is a fancy way of saying H sub 0. We will reject the null hypothesis in favor of, and then we say, well, if we're rejecting this, then we are in favor of this, right? So we will reject the null hypothesis in favor of, and I'm not going to write this in words, I'm going to write it out in context. In favor of the true mean square footage of an apartment being less than, I put the word less in there, 1,250 square feet. Okay, there you go. You did your first significance test. So HITAPSY again. Hi for hypotheses, T for just naming the test. Okay, A is the three assumptions and checking them. P, show the work, get your z-score, get a p-value, and then make your conclusion based on your p-value. All right. There are types of errors that can occur when you are testing claims. There are two. A type 1 error, it's over here in this diagram. A type 1 error is this. You rejected the null hypothesis, but the null was actually true. So this is a problem, right? So you reject H naught, but in fact, H naught is actually true. In context, what does this mean? So for this question we just did, this would mean that we conclude that the mean square footage a lot of writing here, isn't there, of an apartment, well, I'll just say mean square footage is not equal to 1,250 square feet, but it actually is equal to 1,250 square feet. Okay, so that would be what that means. And this would be bad. So this would, if you're this agency carrying out this study, you would conclude this, you would publish this for everybody to see, but it would kind of be slander because it's not true. Okay, so that would be a type 1 error. A type 2 error is here. That is when you reject the alternative, or another way to say that is you fail to reject the null, okay? Um, and but in fact, the alternative is true. So that would be you reject the alternative, but in fact the alternative is true. Okay? What does that mean for this apartment story? This would mean that we conclude the mean square footage is equal to 1250 square feet. But in reality, in truth, the mean square feet is less than 1250. Okay, that's what that means in words. And these both have drawbacks, right? This first one is a drawback to the company, to the people building the apartments. We would put out in the newspapers and online that the mean square footage, they're lying. It's actually not equal to 1250, but in fact it is. So that's like slander. This would be bad for the customers and the tenants. You would conclude, oh, we're all good. The apartments are big. They are 1,250 square feet, but the truth is they're actually less. So all these tenants would rent those places under that assumption. They'd move in and they'd maybe feel cramped for space. Okay. Power is this idea that is not that likely to be tested in May, but it's still worth our time. Okay. Power is the probability of correctly rejecting the null hypothesis, H sub 0, H naught. Okay. In other words, it's the probability of correctly um, correctly rejecting the null when in fact the null is false. Well, yeah, let me get rid of that. When in fact H naught is false. Okay? Power can be increased by increasing sample size. All right. So you want the power to be high because when you reject the null, you want to be you you want to be confident in your answer. Okay. Would the power be high or low up here? Well, let me before I go there. This is really getting at it's getting at this box right here. You reject the null and the alternative is true. So this is good. This is what you want. Being in this box is a good thing, okay? You don't want to be a type 1 or a type 2 error. So the power in this case up here that we just had is very, very high. You can tell for two ways. The sample size is pretty big because we only need to get to 30. 150 is 5 times larger than that. Also, you can tell because the p-value is really, really low. So when we reject the null, I am very, very confident that I should reject the null because the sample that I got, the likelihood of this happening randomly, if this is the truth, is practically zero. So I feel very good about this. The power would be high. So you could, this is just a guesstimate, like 98%, 99%, it's the probability of correctly rejecting the null is very high. Like 0.98 or 0.99 would also work. Okay. Um, you will never have to calculate this, you guys. This is just a concept. Um, letter F. The probability of a type 1 error. Type 1, what is that again? Is when you reject the null hypothesis, but in fact the null is true. Okay? Um, The probability that happens is equal to alpha. What was alpha again? Alpha is that number that is given to you, and it's the cutoff, okay? And so here's the idea. If we set alpha at 5%, that means that if we get a random sample for which the probability of that random sample occurring is less than 5%, like down here is 0.05, we're going to go ahead and reject the null. But if we took a whole bunch of samples, random samples, like if I had every single one of you do a different random sample for this story, there's a 5% chance that if this is the truth, 5% of the samples would fall underneath this cutoff. So there is a 5% of the samples will occur down here, but that doesn't mean the null hypothesis is to be rejected. Fancy way of saying the probability of a type 1 error is alpha. The probability of a type 2 error is 1 minus the power. Because the probability of correctly rejecting the null is the complement of a type 2 error. Put a C here, okay? And this is the power, right? So let's see if that makes sense first of all. The probability of doing this is correctly rejecting the null. Remember we talked about this. That's the power, okay? This one directly underneath it, this is a type 2 error. Well, that would be the complement of this, okay? Because you're, if the alternative is true, there's two situations. Like this probability plus this probability is 100%. If the alternative is true, okay, we're working under just this condition right now. This plus this adds up to 100%, okay? So if the power is the probability of this, and the power, let's just throw a number out there. We thought this was like 0.98. Well, then this must be 0.02. In other words, these are complements, okay? So there you have it, I suppose, all right? So that's where I got that from. Again, very conceptual. The odds of this power thing being on your exam is very low, but I'm throwing it out there. You will be asked like, what is a type? What does it mean to be a type 1 error? What does it mean to be a type 2 error? So this is definitely worth your time and understanding. This is kind of like if you get this, great. You're just that further ahead for the exam in May. All right, folks. Thank you. Thank you.